Hello viewers, welcome to today's video. Wish you happy new year for 2022. So today we'll be looking at rigid zone and its effects, how it affect your design. So I have made a model, so I want to pick this element, this beam 16, to show you what I mean. So I have done the loading and I've run analysis previously, but I'll run the analysis again in two two options. Also, I have extracted the load of this beam and the data, and I have made this sketch for that particular beam. So this is the beam 16, exactly as the beam in the model, and I've also extracted the load like I said. So what I did was to calculate the effect of the load manually. Now, assuming that this has no is simply supported, I did assumption for simply supported, and I did assumption for when the two end are fixed. So this is the moment I got when I assume it is simply supported. So which means that there won't be any movement here, there won't be any movement here. And this is the formula that I use to come about this maximum moment here. And remember, there's an adjoining beam that serves as point load, so I have assumed that point load as well in my manual calculation, and this is what I come with. Again, like, I know that the software has a fixed end moments in its calculation, because the analysis is that the structure is a whole structure, so everything is connected. So I have as the software calculates the fixed end moment. So I also assume that case, and in that case I reduce the value from 8 to 10 to calculate for the span moment before adding it to the effect of the point load, and this is the result I also have for that 159 as the maximum moment. Now, how the software operates to get the moment here, I cannot simulate the same thing manually, because if I do the manual one, it will give me higher moment here, which will be around 150 something, then 130 something in whichever case that I've employed, which I did actually. But looking at the result of the moment from the software, you can see it's very low. So which is the case anyway. So what I'm saying in essence is that how the software comes about that moment is something complex, which uh, I cannot do for this case, for this video. But it doesn't affect the main thing I want us to observe when it comes to using the software, and how we relate it to design as engineer when we employ the software to do our job, our calculation, sorry, for us. So basically, my aim is, like I've mentioned in my previous video, to always have a basis, when using the software, so that when you know where you are going and you know your assumption, then you can be able to effectively utilize the software to carry out all these complex operations for you, and you have a result and a design output that you are confident in. So taking the effect that the software will have some movement here, so I've decided to use this to get this. So if I use 24, of course the movement will be less here. That will be around 30 something. If I add it to this, it should be 108 thereabout. So that's why I don't want to use 24 in this case. Same if I use 12. But generally, if I also apply the principle of moment distribution, then maybe if I have like 25% moment redistribution, if I deduct 25% from here and I split it into the support, that can also help, to model my assumption in this case. But be that as it may, let's go ahead and see what we want to discuss. Now, like I said, I've modeled. So let's run our analysis. Now, before we run the analysis, I have specified the strength of the concrete and the strength of the steel that I want to use. I have defined my loading. Now, in this case now, there is what they call effect. Rigid zone effect plays a very important role in your design assumption. While I was trying to do research on this, so I downloaded this online, and I think it will be helpful for us to understand uh, the effect of this rigid zone. You can see in this case, there's a rigid zone that if you ignore the effect, no rigid end zone, that you have more flexible joint. Now this is like a section. This is actually actually steel, but I think it will be applicable also for concrete when it comes to the member forces. Also, well, maybe you have different connection with steel. So, but generally, uh, beam joining beam also is connected. We are assuming that everything is rigid. So that means you are saying full rigid zone. That means you have most rigid joint at that particular point. Then if you are having partial rigid zone, that means you have intermediate stiffness. So with that, if you go into the software now, this is you have rigid zone. So you can see if you have none, and if you are reducing it, if you say maximum, that means you are saying the full most rigid joint. If you are saying none, then you are assuming this case. And if you are saying you want to reduce by 20 or 25%, you are assuming this case. Now all this plays effect on your result. So uh, let's start by using maximum first. Of course, I have assumed that my beam section in the analysis is flanged, which is the case. So now I click rigid zone, I use maximum. So I say I analyze, let the structure analyze again. And I say, okay, I analyze. Uh, it will take a few seconds. Let's just wait for it. Okay, it's running. You By the time we are done with this, that's why I took the time to do it manually, which is what I always want to do whenever I'm taking on any assignment. Okay, I say go. Now let's examine the results. This figure is for the loading. Let me take this load away. Okay, let's examine the result. Let's say pending moment. That is where we will know. Okay, this is the particular beam I'm talking about. Now, uh, you have to have it in mind that I did not define any point load in this case based on the recommendation of the developers of the software that the software analyzes the structure as a whole. So I did not define any point load, which is the effect of this beam on this beam, but I define it in my manual calculation. So we will see the effect. Anyways, let's go ahead. So now this is the moment. Okay. Now for maximum, the moment is giving me 126.88. Let's note that 126.88. Let's note it somewhere here. Maximum, when our rigid zone is maximum, rigid zone is maximum. That's one. Okay, what is wrong with this? Excuse me. 128. Okay, let's just go ahead. I think I can retain it in my memory. Now, when it is maximum, it's saying that it's 126.88. Okay, so let's go ahead and change the assumption this time. Let's say I reduce rigid zone. Let's reduce it by 25%. We run analysis again. Let's wait for it. Let's take a moment. Okay. The rigid zone effect is actually a very complex something that even I myself am still uh, uh, studying, looking for the effect when it comes to using all these 3D analysis software. So even I myself am still learning in the process. So let's look at it, the maximum now. You can see when it's reduced by 25%, I have 139.307 as my moment. The other one is 128, which is not very far anyway. So, okay, we have 128 and 139. Now let's go back again and change the option now to none. So if I have none, I run the analysis again. I click. Okay, let's wait for it. Okay, coming up. Okay, okay, no, okay, okay. The result is out. Now let's look at the moment in the maximum load case. Now in this case, you can see I have 162. So I have 128 for maximum, 139 when I reduce the rigid zone by 25% and when there's none. Now I forgot to show you while I was running the analysis. You will see the effect on this joint by the time for each options you pick. In this case now, this is directly connected to this. When you reduce it by 25%, you will see there will be a gap, a gap between the joint here and here, just like it's in this diagram. There will be a small gap in between when you reduce it by 25%. Same thing applies when you do not have reduction. There won't be any gap. And when you ignore the effect of the rigid zone and you just go ahead and run the analysis. Now, the question now arises, which of the options will I pick? Just like I've been emphasizing, uh, um, there are a lot of stuff that goes on in the background of the software, and we as a designer, we are trained to idealize and assume that or predict that this is the way our structure will behave. So having that in mind, if I'm employing any analytical software, I always want to make sure that okay, I know what is happening in the background so that I can be able to effectively and efficiently know how to use the software to model and simulate exactly what I want, exactly what my assumptions are. Now, I have three different moments: 128, 139, 162. Mind you, like I said, I did not define any point load in this case, and the developer told me that I need to size my beams appropriately and that I do not need to define any point load. Okay, so now I want a basis where I can actually be confident of the result that I get. So if I calculate manually, this is what I'm having. Manually, I define point load, and you know that now I have 182. Now, if I say okay, let's just say the effect of the fixed end takes place, you know, if I'm saying of course I have this is my 2D analysis. So if I'm saying effect of fixed end takes place, I reduce a bit, so I have 159. So for me, these are the few things that over time, when most of the software comes, I try and take inner look of how it operates and various assumptions. So you can see the one that is closest to me using the software and assuming a none, and I did not define point load because whatever the case may be, if I am constructing, what I'm saying is that this beam, whichever case, based on my assumption, if I'm doing this arrangement, there's a staircase here. Of course, there's a floor space here. So and there's a wall here. So I had to separate this wall with this beam so as to support here. And I am assuming that okay, this beam 16 will help carry this beam 3 on this end, and same thing, this 18 will help carry this on this end. That is my assumption. So if I get to site, this is exactly what I will construct. This is the beam 16 and this is the beam 3. So this is how I will do the reinforcement on site. So always the question is, does your design assumption matches your construction. So if I am having it in that case now, if this result now gives me confident with the option that I picked, that okay, I can go ahead and use the output that the the analytical software gives me. I am confident in that way because when I get to site, this will be the one carrying this. That is how I will construct. So uh, always I want to have a basis for my result. So it's not just that you you get on YouTube or you attend some training and they give you options that okay, when you do this, you click this is your option, then you run the analysis and the result comes. So what is the basics? How do I know that okay, what I'm doing is actually in line with the assumptions that I have made? Yes, the effect that okay, the most of this program operates on the principle that it analyzes your structure as one. That means everything is connected as one. But in the end, I'm not 3D printing the building just at once like that. Now, I'm basically speaking for myself in this case. I'm not saying any assumptions out there is wrong. No, but the way I'm trained, I always want to have a basis where I can actually relate what I'm getting so that I can go ahead and sleep, and not be worried. So I'm not saying you using other options as given by the developer is wrong, whether you use 25% or whether you say none. I'm not saying it's wrong. What I'm simply saying is that I want to have a basis where by when I use it now, you can see that in this case, I don't actually have to bother myself with defining this thing as point load on this, because if I assume this effect, I can see that okay, my analysis result is close to close to what I have manually, so I can take the result confidently. But of course, if I have the rigid zone reduced by 25% or maximum, and I see the moment as 128 or 139, then when I do it manually and I'm seeing and I see that this is short, then for me as a person, I will be worried. Then I will now be questioning what is the software actually doing. So in totality, the software does not have problem, but it is the user that needs to know what the software does. And based on whatever assumptions that you have made your general arrangement, how you have idealized and predicted that okay, you want your structures to be, then that is what you will simulate in the software so that you can get a result as close as possible. So in the end, the saying goes again that you have to do the engineering, just let this only the software do the automation for you. So uh, this concept is actually complex. It's not something that I can exhaust in just one video. And like I said, even I myself, I'm still studying to know what's really the effect of those rigid zone. But in the end, when you design, if it is a commercial project or any other project that you design that and they are actually going to construct, then you want to be careful and meticulous based on the assumptions of some of the software that we employ out there. And the options that, whatever videos that you have seen asked you to pick, and you just go ahead and use without you taking time to actually query the result that you have. So it might actually affect your output. Now we get away with this thing because most of the projects some people take on is not just more than a single suspended slab. But by the time you're having more than two suspended slab, then it calls for concern to know the options that you are picking and the effect what it will have on your structure. This phenomenon I'm pointing out is actually very complex because I might be using simple model and to point these things out. The effect is actually very significant because by the time you take on a project and you come up with a GA and all that, and you might actually be having a column that sits on a beam and it span more than two, three, four stories. Like recently, a project one of my senior colleague is involved in that, the design has been made and the construction was ongoing, and over time, each time they load the building with the subsequent floor, my senior colleague goes around, check all the structure down. So, which is also an advice for us as engineer. By the time you are loading your structure, especially if you are doing high rise building, by the time you are loading your structure, always go around, check the reaction of your structural element to as you are loading it. So he now started noticing cracks on some of the beams, you know. Then he called me that, so we had to like, okay, pick those things part by part manually. Of course, we were not the designer, somebody else designed. So when we started noticing these cracks, we we had to like run this thing manually. So we now discover that the beams supporting all those point load columns acting on them and spanning up to like three, four, five floors fails in shear. So as it fails in shear, we now have to call the attention of the designer. So we now have to check. We actually request that he send us the load so that we can cross check. So eventually, when we got to sit down together and started checking, he himself now discovered that okay, that thing fails in shear. Now I won't say the software that was employed. It's not actually this software we are talking about. It's another software that was employed. So I won't mention it. So we now had to come up with a solution to remedy the situation before loading, the subsequent flood that will still be coming on the structure. So the effect, it's very significant. So don't just take whatever it is. My recommendation is that always have a basis, when you employ some of this software. Now, to him now, the thing pass reinforcement, pass everything pass, but it fails in share. So in maybe in the software that I employed, I know the software he employed, which is another complex software like that, you know, the effect of that shear, it might just be something that he overlooked, So, and then again, one of the challenges was that he didn't effectively utilize depth for beams. So I think that was one of the major reason, you know. But be that as it may, always have a basis for you to take the assumptions and the options that you pick from the software. So I don't want to go much further than this so that the video will not be too long. Thanks for joining me. See you in the next video. Happy New Year once again.